Hello, lovely people. What is up? Today we are solving Leetcode problem number 12, integer to Roman. So we will be given an integer number which we are expected to convert it into Roman numerals. So as we already know, there are 7 different symbols that represent Roman numerals with the following values, as you can see. And the Roman numerals are formatted by continuously appending the conversions of decimal place values from highest to lowest. So the main idea here is if the value does not start with a 4 or a 9, we select the symbol of the maximum value that can be subtracted from the input and append that symbol to the result and subtract its value and convert the remainder to a Roman numeral. And if the value is actually starting with 4 or 9, we use the subtractive form as they're given, which represents one symbol subtracted from the following symbol. For example, let's say we are writing the number 9. We write it like 1 less than 10. So, I, which is 1, and x to represent 10 is 9. Similarly, for 4, we write I and v. So, 5 minus 1 is 4. The subtractive form also includes numbers like 40, 90, 400, 900, etc. So we can use greedy strategy to solve this problem. What we can do is we can start from the largest possible Roman value and we subtract it from the number and then append its symbol. And we can repeat this process until the number becomes 0. So if you think about it, for example, let us take the number, say 1994. So the largest value that is smaller than or equal to 1994 is 1000, which can be represented by m. So 1994 minus 1000 is equal to 994. So the first value will be m, and then again the largest value that is smaller than or equal to 994 is 900, which can be written by the Roman numerals C and M. So 994 minus 900 is equal to 94. So now the new result will look like MCM. And then in the next step, the value that is most nearest to 94 is 90, which is XC. 94 minus 90 is 4. So now the new result will be MCM and XC. And then finally, the largest value is 4, which is IV. 4 minus 4 is 0. And the new result and the final answer will be MCM, XCI, and V. So if you think about it, we are essentially using greedy algorithm in the solving of this problem. So why does greedy work here? Because Roman numerals are built from the largest place value to smallest, and the subtractive forms are fixed. So we create a value symbol mapping in descending order, including subtractive forms. So now that we have understood the intuition, let us now take a look at the code. First, we initialize a list values that stores the Roman numeral numeric values in descending order. Notice that we also include the subtractive cases like 900, 400, 90, 40, 9 and 4. And then again, we initialize another list symbols that stores the corresponding Roman symbols. So here we have to notice a very important thing, that the index alignment matters. So the first value M in the symbols and the first value 1000 in value actually matches. Both lists must match index by index. We then create an empty string result which will store our final Roman numeral. And then we loop through all 13 Roman values, that is for I and range of length of values. And then we code the greedy part using while num is greater than equal to values of current index, values of I. So as long as number is greater than or equal to the current value, we add symbol and subtract value. So we increment result by symbols. The current indexed symbol, that is result plus equal to symbols of I, the current index I. and then we decrement num by value, that is num minus equal to value of I. So why are we incrementing the result again? It means add the current Roman symbol to the result string. This essentially expands to result equal to result plus symbol of current index I. This line is essential to build the Roman numeral step by step. And decrementing the num by value means subtract the current value from the number. It is same as writing num equal to num minus value of current index I. This line reduces the number after using one Roman symbol. So then finally outside the loop we return the result. So if you look at it, the code is running perfectly. Here the time complexity is fixed time complexity because the size of the list is fixed, that is 13, and the maximum input is bounded to 1 to 4000, that is 399. So the time complexity is constant time O of 1. It does not grow with the input size. Same with the space complexity. The space complexity is constant space O of n because we have fixed size lists. So that's all for today. Hope you guys enjoyed today's video. See you in the next one. Bye bye.